So welcome back. This is now our 8th lecture together, and it is 1:40 business, September 23rd. And we are going to be working on chapter 5, which is on regression. Regression and correlation are very closely related. In fact, share screen. In fact, some of the regression stuff we actually did last time, but chapter 5 is on regression. And regression is the act of fitting a line to your data. If you have a scatter plot and your scatter plot looks like this, would you be able to conclude that there's a reasonable likelihood that your data is linear? You obviously can't conclude that it is or is not definitively, but does the data support the fact that it may be linear?
Maybe.
If your scatter plot looks like that, maybe?
Yeah.
Okay, maybe. Positive or negative correlation?
Positive.
Positive. You know, so you can see it goes up, looks kind of linear. If it's linear, I should be able to fit a line to my data that is the best line for the data. Would you agree that this line best fits the data?
No.
No.
Okay, what about this line?
No.
Okay, what about this line?
Yes.
Well, how do you know? Yeah, go ahead.
Like a little more to the bottom, I think, coming through the origin. Yeah.
Like that?
Yeah, I think so.
Okay, well, let me see this question. What makes one line better than another?
Because it's like closer to where most of the dots are in my
Okay, so let me see this question then. The line that I just drew and this line, which one of those is better?
I think the one you just drew, because it crosses through more points.
Okay, so that is your gauge for the quality of a line. What if I can draw more than one line that goes through the same number of points? How would I determine which one is better?
Kind of like where most of them, I don't know how to explain it, but it's where like the direction of most of them are, like where they're more clustered around.
Okay, so that's great. But would you agree that if I had a mathematical approach to doing it, it would be more accurate than anything I can do by just eyeing it? Would you agree with that statement?
Yes.
Okay, so luckily for us, there is a mathematical approach, and it's based upon the following ideas. I'm going to draw a scatter plot with just 3 points, because if I only have 3 points, it makes it cleaner what I'm trying to demonstrate. So suppose someone came along and said that this was, in their opinion, the best fit line, the best line you could possibly draw. And you wanted to ascertain whether or not that was true. So here's one thing you can do. And here's one thing you should do. What we're going to do is we're going to calculate the vertical distance between each point and the line. Okay, we're going to calculate our vertical distances. Now, when I only have 3 points, I only have 3 vertical distances. It's not a lot of work to compute them. If I had 100 points, I'd have to compute 100 distances. It's a little more work. But with a computer or a calculator, I don't care how many I have, it's pretty much the same. So I'm going to compute these things, and I'm going to call these guys the deviations. So I'm going to call D1, D2, and D3 the deviations or the residuals. So D sub I equals the ith deviation or the ith residual. So I have the first residual, I have the second residual, and the third residual, which by the way is defined as, well, actually let's leave that for later. But for now, it's just this vertical distance. And what I'm going to compute is I'm going to do D1 squared plus D2 squared plus D3 squared. I'm going to square my deviations, my residuals, and then I'm going to add them all together. And when I do that, I get a number, right? This is some number. You agree?
Yeah.
That's just some number, correct? Now, if you came along and you said, no, I believe this is the best line, then what I would do is I would do the same things. I would compute your D1, your D2, and your D3. I'm going to call them D1 prime, D2 prime, D3 prime. And I'm going to compute your D1 prime squared plus D2 prime squared plus D3 prime squared. And that's going to equal some other number. By comparing those two numbers, what do you think is a good metric, a good methodology for determining that one of those lines is better than the other?
Maybe a smaller distance between the points to the line.
Well, so you want to look at each deviation individually?
And
Or
in totality. So like after you add them all up, you see which number is smaller.
correct. Whichever of these two numbers is smaller would be the better line. So all I have to do to figure out the best fit line is simple. Examine every single possible line one can conceivably draw, calculate each deviation, square them all, add them all together, and compare all of those numbers and pick the one that's smallest. Does that seem like a reasonable approach to determining the best fit line?
No.
Why not?
There's like so many lines you can draw across like the spectrum.
Yeah, there's infinitely many lines, right? How in the world do you check each of the infinitely many lines to determine which one will give the smallest? The answer is you don't have to. Because by the magic of calculus, without getting into the details, you can mathematically determine which line will give the smallest number without actually looking at any line in particular. Now, this is not a calculus-based course, so I can't go through the derivation. And some of you in the past, I've had students who say, yeah, but I've taken calculus, I want to see it. And I go, okay, well, have you had multivariable calculus? And they go, no. And I go, well, sorry, can't do anything. You need calculus 3 for this. There are 3 semesters of calculus. And then when you get there, it's actually a pretty straightforward result. It's like 3 or 4 lines of work. It's not a lot. But the point is that we have a mathematical way of calculating the best fit line. And luckily, our calculator does it for us. In fact, last week, or not last week, but on Tuesday, if you recall, we did an example getting the best fit line, correct? Right? Y equals ax plus b, and A and B were on there and we plotted it. Remember that? So we already know how to find the best fit line. It's called using your calculator to get it for you. Okay, that is how we're going to find the best fit line. We are not going to do it from scratch. We're not going to do it by hand because we don't have the tools. However, luckily, we can still give a formula for it. So the best fit line is a linear equation, y equals ax plus b. And we have nice, simple formulas for A and B. A is given by that. What is everything in that formula, by the way? What is R? What is S sub Y? What is S sub X? These are things that we should know. What is R, S sub Y, and S sub X? And anyone? Were you guys here last time? What is R? Guys, you're making me question my efficacy as a
Right.
teacher.
Is it the strength of correlation?
It's the correlation coefficient, which your calculator can provide for you. What is S sub Y?
I believe it was it the mean of all of them added up, or
No, S sub Y is the standard deviation of the Y data.
oh, okay, yeah,
And what is S sub X?
the standard deviation of X then.
Standard deviation of the X data. So that gives us A, which is the slope. This is the slope of my line. B is Y bar minus A X bar. What is Y bar, A, and X bar?
Y bar is that would be the mean of Y, and then minus the X mean.
Right, so what is A?
A would be our slope.
A is a slope, which we just calculated. So you get A first, and then you plug it in and you get B, or you let your calculator do all the work for you. Do you guys know who was the one who first came up with the idea of the best fit line and how to find it? Anyone know their mathematical history? Or any mathematicians throughout history by any chance? Anyone know any mathematicians?
Pythagoras.
No.
Okay, Pythagoras, who was the mathematician, but he didn't do this one.
Yeah.
Any other ones?
Newton.
The great mathematician, but he did not do this one. It was after Newton. Newton was around in the 1700s, and this was done in the 1800s. Using calculus, of course, which Newton invented, so it had to come after him. No, nobody doesn't know the math people? Anyone ever hear of Leonard Euler?
No.
Okay, it wasn't him. Although he was pretty amazing. He wrote 27 volumes of mathematical work in his life. It's the most ever, the most prolific mathematician ever, 27 volumes. And he was going blind. He was developing cataracts, and he knew he was going blind. So before he went blind, he taught himself to write blindfolded, so that after he went blind, he can continue to write and do math. Pretty inspiring. Anyways, his name was Gauss. Carl Gauss was the one who came up with this. And Carl Gauss, great mathematician. If anyone ever asked you who proved something and you had to take a guess at it, go with Gauss. You'll probably be right half the time. Anyways, so this is the best fit line. Are there any questions on how to either get the best fit line by hand or how to get the best fit line on your calculator?
Yeah, I forgot how to do it on the calculator already.
All right, so let's do an example then. Let's do an example. Oh, I'm sure there's a good example here. Okay, so here's a good example. I feel like we already did this one. So is there a better, well, it's a good example because there's not a lot of data points. But did we do the coral reef example last time?
Yes, I still have it in my calculator.
Okay, well, let's just write it out again. So temperature versus growth. And we have 29.68.
Body you. What other song do you want?
I don't know. What songs do you know?
Let me see. I'm pretty good at knowing their songs.
Hey, it's a lot more entertaining than my class, I'll tell you that much. 2.6, 30.48.
Do you ever feel like a plastic bag drifting through the wind, wanting to start again? Do you ever feel it's so
Catchy.
perfect, like a house of cards, an open caving in? Do you ever feel
Jasmine.
very deep, 6 feet on the ceiling, and no one seems to hear a thing? Do you know that we're making a sister group right now? There's a spark in you.
Okay.
Come on, Leah.
Let's take it over under here for how long it's gonna take for her to realize that she's live. What do you guys think?
Let's say like 2 minutes at least.
I think they'll finish the song.
time.
Can't you just mute her though?
I know, but this is so entertaining though. I don't want to. All right, fine. I'll mute her. All right, I was having too much fun. Okay, so we have our data points. Let's go. Thank you for that interlude, Jasmine. If you ever come back, I'm gonna write in the chat here. Hold on. Math better than music. Okay. Anyways, so what's the first thing we do?
We put down the numbers in our calculator.
Yeah, list 1 and list 2, right? Remember how to do that? How do we get list 1 and list 2? And remember?
Wait, sorry, what?
How do I
Look.
how do I put the data in? How do I put the
Music.
data in? So how do I put it into list 1 and list 2?
I don't remember.
Hit stats
Okay, stats and then edit, right?
and then edit.
You just go down.
Well, you put in L1, you put in 29.68, you put in 29.87, you put in 30.16, 30.22, 30.48, 30.65, and 30.9. And then L2, 2.63, 2.58, 2.68, 2.6, 2.48, 2.38, and 2.26. Right, so right now what you should have is this. Right, Jasmine, you there? Probably can't hear me over the music. Okay. So what do I do once I have all my data in?
Was it second calc or no?
I'm asking you, what do I do once I put my data in?
You go to stat plot, right?
Okay, second stat plot. You make sure that your stat plot is what?
On.
On. Now, if you did it yesterday, it should still be on. But if not, you got to turn it on. Then what do I do?
Adjust the window.
Adjust my window. I got to make sure I have all my X values and my Y values. So what's a good X range here?
It's 29 and 31.
29 and 31. I think that works. And what's a good Y range?
2 to 3.
Okay, 2 to 3. Whoops, I just hit the wrong button. 2 to 3. Okay, and then graph. And you should have your scatter plot. Mine looks like this. Correct? All with me?
Yes.
Okay.
So at the beginning, you said you clicked stat and then what?
At the very beginning,
Yeah, you lost me at the beginning.
that's a good place to be lost. Stats and then edit. You got to put your data in.
Stat and then edit. Oh, okay. I see what you mean. Thanks.
Sure. Now, how do I calculate my best fit line?
I think you go to stat calc, right?
Calc. And then do what?
I have written catalog here, but I don't really know, like,
You have your what? I'm sorry? I didn't,
I wrote catalog, but I don't really know what I meant by that.
no, second catalog was only to turn your diagnostic on so you can see your R value.
Oh, okay.
Once you've done that, you don't have to do it again.
Was it the last one?
Was what the last one?
Were we supposed to put second calc and then put number 7? Or
Number 7. No, 4.
number 4? Okay.
Second calc, and then lin reg AX plus B, which is number 4. And what does it say? It should give you your A, it should give you your B, it should give you your R. Does it do all that? Anyone with me?
I put second calc and I didn't get that for my fourth one. I have some.
You hit stats and then calc, right? Not second calc, stat calc,
Oh, stat calc. Oh, okay.
stat calc.
Okay, I found it now.
And then you go to lin reg AX plus B all the way down. What's your R value?
It's negative 0.86.
Negative 0.864. And what's your A?
Negative 0.303.
And what's your B?
11.692.
Okay, so what is your best fit line? Quite often you'll see it with a little hat on top to indicate the best fit line. What's your best fit line here?
It would be negative 0.303x plus 11.692.
Okay, so now what we're gonna do is do what?
We're gonna put the equation back into the calculator to get
And
the
where do we put it in?
y equals.
Y equals, good. And then we hit what?
Graph.
And you should hopefully have something that looks like this. Yes,
Yes.
and that's it. That's how you find the correlation. That's also, by the way, how you find R squared. How do I find R squared?
You square R.
Square R, so 0.746, which is moderate strength. And you have the best fit line, you have everything you need. Does that make sense?
Yes.
Now, question for you. In this example, would you say, based upon the results of your analysis, that the growth rate is only dependent upon the temperature and nothing else?
No,
Why not?
because there's a lot of factors in a coral reef.
Okay, so let me have a follow-up question. You see how the growth rates are different for the different data points?
Yes.
How much of that difference can be attributed to temperature versus everything else that we're not considering? What percent of the variability in the growth rate can be attributed to temperature? 10%, 20%, 50%, 100%, 0%. What percent of the variability in the growth rate, the fact that these values are not all the same, can be attributed to temperature, different temperatures, different growth rates? That makes sense. And then there's other factors. So what percent goes to growth versus everything else? And by the way, I am looking for a very specific number here.
Is it one we have to calculate or is it?
No. Well, we do have to calculate it, but we don't have to do any more math in this particular problem. The answer is 74.6%. In other words, your R squared value is the percent of the variability in the response variable that can be attributed to variability in the explanatory variable. Growth rate explains 74.6% of the temperature variation. The other 25.4% will be explained by what?
Everything else.
Everything else. Sunlight, pollution, whatever else is out there. All,
This is only for this specific coral reef, right?
Well, the 74.6% came from this problem, but R squared will in general,
But wouldn't like a different coral reef with, let's say, more pollution than this one have a bigger impact on the pollution than like this?
yeah, this R squared is for this data. Different other data would give me different R squared value. I can only talk about this experiment right here.
Okay.
Okay, so in general, R squared gives the variability in the response variable that is attributed to variability in the explanatory variable. So a good correlation, a strong correlation, means a big R squared value. They're strongly correlated means most of the variability is attributed to this. R squared 0.9, 90%. That means this is really the single greatest and most important factor, and everything else is minor. You get something like an R squared of 0.3 or 0.2 or 0.1. It's like there's all the other stuff is really the ones that do everything. This is a minor contribution. So it's not the R value that gives the strength, it's the R squared value that gives the strength, which is why we use it. Does that make sense?
Yes.
Okay, of course, I'm not proving this. The worst thing about introductory statistics versus other areas of math is that a lot of this stuff just you have to accept. It's just, you can't prove it. The math to prove it is beyond the level of the course, and it just, there's no time. Sometimes you just got to say, I'll just accept it and go with it. And statistics, unfortunately, has a lot of that. And this is one of those examples. Okay, but this is a very important result, probably the most important conceptual result of the chapter. What the R squared value is measuring is the percentage of the variability in the response variable attributed to variability in the explanatory variable. Okay, does that make sense? Hopefully for everyone. Unless you're listening to music, in which case I don't even know if you're here.
Yeah, it makes sense.
Okay. All right. So now some facts about regression. Some facts about regression. So, number one, if you switch the explanatory variable and the response variable, the correlation does not change. But the best fit line does. Okay. And you can really see that in the formula for the slope. The formula for the slope of the best fit line has R, which does not change, but has SY over SX. If you switch them, it becomes SX over SY, which will in general be a different slope and therefore give a different line. Is that reasonable?
Yes.
Okay.
Yes.
Two. Whoops. Two. Going back to this example here that we just did, we didn't actually write it down, but let's do it now. What is X square, X bar, and what is Y bar? For that same data, what is X bar and what is Y bar? We still have the data on our calculator, so it should only take us, yeah, I already have it. So what is X bar and Y bar? How do I use my calculator to compute X bar and Y bar?
Was it in the calc area, the stats calc?
Yep, it is. So how do I find it? Anyone?
Would it be two var stats or?
Well, if I'm just trying, it would be two of our stats, yes, stats, two var stats, yes.
So would it be 0.42 or 0.43 actually?
For X bar,
I think so. Oh no, sorry, it's 30.28. I was looking at a different one. Sorry.
30.28, and what is Y bar?
2.52.
Is everyone getting those? Are we all agreeing? Yes? Guys, hello. Earth to everyone.
Hello.
Well, thank you. I wasn't just saying hello, but I appreciate that. Do I got to take attendance right now to see who's actually here? I don't want to.
I'm here.
Oh, thank you. That's two. Where's everyone else? Speak.
Hello.
Put them in
Hey.
the chats. I know you're here.
I'm here.
Hello.
I'll
I'm
tell
just
you
trying
what,
to understand.
this COVID shit. I'm telling you, man. Nothing beats being in person, right?
Right.
Hmm.
Yeah.
So easy to get distracted online. Trust me, I know. I know. Unfortunately, at the end of the semester, grades don't care. So you gotta really, you know, give it the old college try, no pun intended. So tell me, does everyone with me for getting X bar and Y bar? It should be all of a 3 seconds motion, couple buttons and bam, you should have them. Does anyone not know how to get X bar and Y bar?
No. Like I know, we know.
You do know, so we're okay with it?
Yeah.
Yeah.
And do me a favor, go to your graph. Go back to your graph. And I would like you to move the cursor to 30.28, 2.52. And tell me what you noticed about that point.
Where do you want us to move the point? Sorry.
To X bar, Y bar.
Okay.
What do you notice about that point? Anyone?
Is it the nearest point? Like that's like a point near to it.
That's not what I'm looking for. What I'm looking for is the fact that it's on the line. X bar, Y bar always falls on the line. Which means if you have to do it by hands, if you have to guess the best fit line by hand, find X bar, Y bar, make a point, and then only consider lines that go through that point. And try to find the best one that you can. Okay?
Okay.
Those are a couple facts about the best fit line. Now, if you recall, how did we define the ith residual? So recall from a few minutes ago. Recall for a best fit line.
Deviation. Bias is it's deviation, right?
Yes, it is the observed point minus the predicted point, or the observed value, I guess is better. Observed value minus the predicted value. So what does that mean? The observed value minus the predicted value.
Would that be like the actual point compared to where the point would be on the line?
Yes. So let's go back to the picture I had earlier of just a few points, like there, and there. And here is the line. And if we look at this point right here, then we knew that this was the residual. This was a deviation. So this one is the actual observed value, right? That's the actual point. And this is the predicted from the best fit line. The reason I kind of didn't want to do it earlier is because earlier I didn't actually have a best fit line. I had the observed points, and then I had my guess for what my best fit line was, but we hadn't yet actually really definitively established it yet. So now that we have a method for finding the predicted line, now I can define my residual to be the observed value minus the predicted value. So if a point is above the line, what can you tell me about its residual?
It should be positive, right?
It's positive. And if the point is below the line, what can you tell me about its residual?
It's negative.
It's negative. Now, if you add up all the residuals, you will always get 0. The sum of the residuals is always equal to 0. The reason why we square the residuals before adding them is because if we didn't, we'd get 0 for every line. This is no matter what the line is, by the way. This is not just the best fit line. This is for all lines. So the reason why we square them is so that we don't have this cancellation effect. Okay, does that make sense?
Yes.
Sum of the residuals is always 0, okay? Above, it's positive, below, it's negative. Now, if we go back to our coral reef example, if we go back to this example here, so I'm going to copy this entire thing here. Okay, so I go back here. Question for you. What is the predicted growth for a temperature of, let's say, 30.37 degrees? What is the predicted growth for a temperature of 30.37 degrees?
Would you just plug that in for X?
Exactly. All you do is you say, okay, I will predict negative 0.0303 times 30.37 plus 11.692. This is the whole point of the best fit line. We're basically saying, based upon my data, this is the best thing I can predict for this line. So if you give me any other points, this is what I'm going to use. So I get negative 0.303 times 30.37 plus 11.692. And that tells me that I would get 2.49, whatever the units are. Seems very reasonable, correct?
Yes.
Okay, so follow-up question. What is the predicted growth for a temperature of 35 degrees?
Same thing.
No,
No.
that's why I picked this one. Tell me why I can't just do the same thing.
Oh, because it's not in our range.
Exactly. Our data is from 29 point something to 30 point something. To be able to assume that the same pattern holds outside the data is called extrapolation. You cannot, in general, extrapolate your best fit line outside the range of your data set. And every test that I've ever seen, there's always been that one question of plug this in, does it or does it not make sense? And what they're looking for is, no, it does not make sense because you are extrapolating and you are not allowed to extrapolate. So don't do it.
Can you move it a little down so I can see the?
Is that better?
Yes.
Okay.
So would you say like it's important to write down the range every time you're doing like a question just to make sure?
You don't have to write it down, but you should certainly be cognizant of it,
Okay.
right? You should certainly be aware of where you're starting and where you're stopping. And then, it's like kind of like with me when I do trigonometry, I instinctively on my calculator check if I'm in degree or radian mode before I do a problem because I know that it matters. You want to get to the point where you instinctively are keeping an eye on the range of data to know whether or not you're allowed to apply something or not.
Okay.
Okay, but if you want to write it down, I have nothing wrong with that. 100%. Does that make sense so far? Yes, no?
Yes.
Yeah.
Okay, so now suppose here's your data set. And suppose I have, just for simplicity, so, okay, well, Hope everything's okay. Suppose I have the following situation. Okay, suppose I have the following 3 points. If you had to draw a best fit line to these 3 points, how would you draw it? Oh, wait a second, I want to change one thing, 1 second. Sorry. Let's do it like this. So here are my 3 data points. Okay, if you had to draw a best fit line for these 3 data points, how would you draw it?
Maybe in between the 2 points that are next to each other and then connected to yeah,
So something like this,
yes,
is that reasonable?
I believe so.
Okay, I think so. I think it looks pretty good.
The reason you changed it, right, was because if one's like more up, like in between the 2 points, you would just do the.
Not exactly. I changed it because of what I'm about to do next.
Oh, okay.
Let's say I were to remove this one. Let's say I were to remove that data point. What would my best fit line look like now?
You just connect the 2 dots.
It would just connect the 2 dots, right? Something like this, correct?
Yes.
Which means this guy here had a huge effect on my best fit line. Having or not having that one has a tremendous effect on the best fit line. Would you agree?
Yes.
We call this an influential observation. Because its presence or lack thereof significantly changes the situation. Just by looking, if you put that one back and you remove one of the other 2, would things change drastically?
No.
No. So the other 2 would not be influential. Okay. As a general rule, outliers in the X or Y direction are often influential for correlation. Outliers in the X direction are often influential for the best fit line. And by the way, I keep calling it the best fit line, but you should know the best fit line is also called the least squares line. Because if you remember how we get it, we square the deviations, we add them, and we take the smallest one. So you might see that notation, the least squared line or the best fit line, but they're really talking about the same thing. Okay? What do I mean by an outlier in the X direction or an outlier in the Y direction?
Like if the X is greater than, like, we use that IQR rule if they're outside of the range, right?
Yeah, but I'm thinking if I have a scatter plot and I say, oh, this is an outlier in the X direction just by looking, or an outlier in the Y direction, what does that mean in the X direction or in the Y direction? And yes, if you wanted to, you can make a box plot for just the X, use the 1.5 IQR rule, or a box plot for just the Y and use the 1.5 IQR rule, 100%. And that's 100% valid. But from a graphical perspective, what would the difference between an outlier in the X direction or an outlier in the Y direction?
It'd either be vertical or horizontal.
Yeah, suppose this is my data right here with this. Is there anything wrong with that guy's Y value? Is its Y value strange?
No.
No, it's the same Y values as all the rest, but it's an outlier in the X direction. Versus that, whose X value is normal, but it's an outlier in the Y direction. And of course, versus that, which will be an outlier in both directions. Does that make sense?
Yes.
And the other things in this chapter I've already mentioned. I don't see anything else that I haven't covered that you really need to know. So that takes us to the end of 5. Now, I did notice that I did not put up the chapter 4 homework yet. I happened to notice that today. So I'm gonna end class a little early and put up the 4 and 5 homework. And it's Thursday. And I don't want to only give you a week for 2 chapters, but I'm gonna have them both due the following Tuesday. Should that be enough time?
Yes.
Okay. That's like 12 days. So I'm gonna have both 4 and 5 due the following Tuesday. Okay. So are there any questions on anything we did today?
No, thank you.
All right then. Well, have a wonderful night, everyone. Have a wonderful weekend. Let's plan though to have a quiz because we have to have 10 quizzes and we've only had 2 so far. So let's plan to have a quiz. We're in week, this is the 4th week already. And we've only had 2 quizzes, so we gotta pack them in. How about a quiz on chapter 3? We haven't had a quiz on chapter 3 yet, have we?
I thought you had already said that we're gonna have a quiz, both quizzes this week.
Oh, okay, so I already announced that.
Yeah,
Okay, fine. So the to-do list quiz on 3 due Tuesday. Homework 4 and 5 due next Tuesday.
Is it gonna be the same exact way they did this quiz?
Well, it's not gonna be 3 attempts. It'll be 1 attempt.
No, I know. I only did 1 attempt, but I'm just saying
Yeah.
how it was done.
I'm just gonna pick 10 questions from the test bank. Yeah,
And it's gonna be posted. Okay, cool.
yeah,
There's
I
gonna
mean,
be
I'll make sure to link it this time. I didn't link it last time because the linking thing is a new thing for me. I've never done it before, so I don't have it internalized. But I'll right here, link them all. Okay, so now I know to link them all. Sound good?
yes.
All right, so I'm gonna do all that right now, so you have it. And other than that, I'll wait till everyone leaves and I get to see who's pretending to be here, of course. But other than that, I will see you all Tuesday.
All right.
Thank
Thank
you.
you so much.
Thank you.
Have a great weekend.
Thank you, Professor.
Have a good weekend. Bye-bye.
Have fun watching your shows.
Oh, if I can ever get around to finding time for them.
Professor,
Yeah.
when you said that you were gonna be going to Arizona for like a tennis thing,
Yeah,
is that gonna be like the week after this one or?
that's a week from tonight. I'm leaving a week from tonight.
So is there gonna be class in session?
So there will be class. I have to decide either getting a substitute or taking out my laptop at the airport and giving class from there, which is what I'll probably do, because that way I could just end early if I have to.
Okay,
Why? Why do you ask?
I was just wondering.
Okay. Interesting. Okay. Well, anyway, that's the plan. Okay.
Okay, thank you.